Example 5. Once again, I'm writing the equation of a tangent line. Same thing, write the equation of a line. And it's giving me a function. It's saying it's tangent to this function through x equals 5 with a rate of change of -3. Well, this is telling me that my slope, again, remember, writing the equation of a tangent line, you need two things. You need a point, you need a slope. Here's my slope, m is -3. And my point, I've got the x value of my point. I just don't have the y value of the point, but I do know that the point that I need to write for this tangent line is also a point on this function. So I'm going to use this function just to give me what the y is that goes with it. 5 squared is 25 minus 20 plus 1, and you end up getting f of 5 to be 6. So there's my ordered pair, 5, 6. Now with this information, I can write the equation of my tangent line. Y minus y1 equals mx minus x1. We'll leave it like that. Example 6. Consider a circle of radius 5, centered at 2, 3. Find an equation of the line tangent to the circle at the point 2, 6. I'm going to sketch this. My circle is centered at -2, +3. I'm a very visual learner, so I like to sketch things out when I can. And my radius is 5. So I'm going to go 5 units in each direction. 1, 2, 3, 4, 5. And I'm just sketching it just to get me an idea of what 1, 2, 3, 4, 5 this circle might look like. 1, 2, 3, 4, 5. And here it is. All right, pretty good. Find an equation of the line that's tangent to the circle, meaning it just touches the circle at the point 2, 6. All right, the point 2, 6 would be 2, 1, 2, 3, 4, 5. So it would be right here. So it's got to be tangent to the circle at 2, 6. So I've got the point. I don't have the slope though. So what do I have to do? And let me just sketch what the line's going to look like. Here's my tangent line. What am I going to have to do to get the slope of this line? Well, why did they give me the center of the circle? There has to be a reason for it. And the reason is this. Do you remember from geometry? What is true about radii and tangents? Well, they intersect at right angles. For that reason, now I can find the slope of the radii using these two ordered pairs, and then the opposite reciprocal slope would be the slope of my red tangent line. So let's do that. The slope of my radii equals y2 minus y1 over x2 minus x1. 6 minus 3 is 3. 2 plus 2 is 4. So that's the slope of my radii, but I want the slope of the tangent to that. And the slope of the tangent will be -4 over 3. Now I'm going to write the equation of the line. Y minus, I have to use the 2, 6 point, y minus 6 equals -4 over 3, x minus 2. And now I have the equation of my line.